In the diagram, O is the center of the circle, ABC. And angle ACB is equal to 36 degrees. The line DC is tangent to the circle at C. And so here we have this diagram. Calculate the value of angle ABC. And so what we're gonna do is we're gonna highlight this particular angle that we need to find. And so we have to figure out the size of angle A, B, and C, all right? So notice that we have this triangle right here. All right, this is a triangle that we are highlighting. All right, and so what we have here is we have to figure out what is angle ABC. Well, they really want angle B, and so that's the angle that we really want. So let me highlight that. And so this is the angle that our eyes should be on, right? Angle B. And it's in the triangle ABC, all right? Okay, so what we need to do is we need to figure out what is the size or what is the value of this angle. Now we can use a formula, we can use a theorem. The theorem here is headed angles in a circle, angles in a semicircle. And it states that the angle in a semicircle is 90 degrees. And so if we look at this diagram, we have the diameter AB, and this diameter divides the circle into two halves, this semicircle and also this semicircle. And if we look at angle C right here, it's 90 degrees. So the angle in a semicircle is 90 degrees. And we have something similar here. We have the diameter AC. It divides the circle into two halves, this half, all right, as well as this half, all right. And we have this angle B. The angle in a semicircle is 90 degrees. And so we apply that theorem. And so that means that angle ABC is equal to 90 degrees. Next, we have to determine the size or the measure of angle BAC. So the first thing that we're going to do is we are going to, let me erase everything. The first thing that we're going to do is we are going to highlight this angle. And so let's highlight it. So we have angle B, right? Angle B, A, and C, all right? And so this is the triangle that we're looking at, right? And what angle are we looking for? The angle that we're looking for is the angle that's in the middle. That's angle A. So that is what we have to try to find. So we have to figure out, okay, what is the size of this angle, right? What is the size of angle A? Now what we do know is that we know that this right here is 90 degrees. So this right here is 90 degrees. And so what we have here is we have 90 degrees, we have 36 degrees, and we have this angle that we need to figure out the size of. Okay, so, well, this is a triangle, and angles in a triangle add up to 180 degrees. So that means in order to figure out the size of angle A, we have to add 90 and 36 degrees. When we add them together, we're going to take that sum and subtract it away from 180. And so that's how we're going to do it. So we have 180 minus 90 plus 36. Again, 180 minus 90 plus 36, 90 and 36. And then that gives us 180 minus 126. And 180 minus 126 is definitely 54 degrees. And that's because angles in a triangle add up to 180 degrees. Next, we have to figure out, okay, what is the size of angle BCD? What is the size of angle BCD? All right, so let me erase all ink and let's highlight this particular triangle. And so we have angle BCD, all right, let's highlight this particular angle. So we really focusing on angle C. So we have B, C, and D, all right? B, C, and D, okay? Now, what's our goal? Our goal is to figure out what is the size or what is the measure of angle C. And so what we have here is we have B, C, and D, okay? And what we're really trying to figure out is what is the size or what is the measure of this angle right here. All right, that's what we're trying to figure. What is the size of this angle right here? Now, in order to figure out the size of that angle, we know that we can use the alternate segment theorem. That's going to be helpful. And the alternate segment theorem states the following, that the angle that lies between a tangent and a chord is equal to the angle subtended by the same chord in the alternate segment. So what does that mean? That means that, notice we have this chord, right, AC, and we have this tangent, which is this black line. The angle, which is theta, that lies between the tangent and the chord, this angle right here, theta, is going to be equal to this angle that is subtended by this chord. Now we know that theta is subtended by this chord because the legs of theta, the legs of this angle, rests on this chord. And so that means that these two angles are equal. Now, what do we know already? Well, we already know that this angle A, we already know that angle A is what? We already know that angle A is 54 degrees. We saw that earlier. And so we can use the alternate segment theorem to figure out the size of angle C, right? Because we have CB, that is a chord, and this tangent right here, this line is a tangent line. So we have a tangent line and we have a chord, and this angle theta lies between the tangent line and the chord, which means that it's going to be equal to this angle that is subtended by the same chord. And we know that this angle A is subtended by the same chord because if we look carefully, right? If we look carefully, the legs of this angle, angle A, the legs of it rests on the chord. The legs of it rests on the chord. And so that means that this angle that measures 54 degrees is subtended by this chord that is in yellow. And so what does that mean? That means that these two angles are equal. So that means that if this is 54 degrees, this must also be 54 degrees as well. And so what we have is angle BCD is equal to 54 degrees. And that is because of the alternate segment theorem.